So continuing with section 1.5, when we have fractions, our goal is to get rid of the fractions. So in order to get rid of this first fraction, I'm going to have to multiply every numerator by 6. So this gives us 6 over 6 plus 6 over x plus 1 equals, shh, please, 6 over x. Okay. Now, we also need to get rid of x. So we're going to multiply every numerator by x. So we'll get 6x over 6 plus 6x over x plus 1 equals 6x over x. Oh, yeah. And what you'll notice here is that these 6's cancel, those x's cancel. So let's do that in this step. So we've got just x plus 6x over x plus 1. Guys, can you please be quiet because I'm trying to keep teaching and I'm recording too. Now we have to multiply every numerator by x plus 1.
Oh, okay.
Which is a pain in the butt to have to do for however many times there are denominators. So I'm going to show you a quicker way of doing it on the right-hand side.
Okay.
So here we have x times x plus 1. Uriah, can you do me a favor and close my door, please? Thank you. Plus 6x times x plus 1 over x plus 1, 6 times x plus 1. And what you'll notice is that it cancels when it was that thing being multiplied. So now we're going to simplify a bit. X times x plus 1 is x squared plus 1x. Then we have plus 6x equals 6x plus 6. All we did was distribute. At this point, we're going to combine like terms and try to get everything on one side. X squared plus 7x equals 6x plus 6. Subtract 6x and subtract 6. For those of you that are in my 6-hour class, you should be working on your floor plans and labeling them with variables like back there. So this is x squared plus x minus 6 equals 0. I do not care how you solve this. You can solve using quadratic formula. You can solve by factoring. It's up to you what you are most comfortable with. For me, this one is easy to factor. So my answers are x equals -3 and x equals 2. Now, that was super long and drawn out because we had 3 different denominators. I'm going to give you a Post-it note so that you can put it up top.
Okay.
Jen, is there any worksheets that I'm missing? Just one, right?
Probably just one. Yeah, we've only done one worksheet. Yeah, give me a minute. So, let me show you an alternate version of this. 1 over 6 plus, I'm just going to rewrite the original question. If I was trying to find a common denominator, Your common denominator here would need a 6, an x, and an x plus 1. So what I could do is multiply this to every numerator right away. Shh, please. So I'm just rewriting it and leaving space so I can put the 6, the x, and the x plus 1. Plus x plus 1 was already there on the bottom. The 6, the x, and the x plus 1. And then same thing for that last one. 1 over x, the 6, the x, and the x plus 1. Because when I do that, these 6's cancel in that first fraction. Sorry, I'll go a little slower.
No, I'm just writing the denominator.
Okay. The x minus, or excuse me, x plus 1 cancels in that second fraction. And the x cancels in that last one. So what we're left with is, ooh, geez Louise, x times x plus 1 plus 6 times x equals 6 times x plus 1, which is exactly what we had many, many steps later down there.
Yeah.
I prefer this way where I can see the denominators all at once. I multiply every single thing right up front, and then things cancel. And then I
Yeah.
can finish solving. But if you'd like to take it step by step, you can certainly take it step by step. And that is every time you have fractions. Okay? So, for number 3, we have fractions again. But this particular fraction can be factored. This breaks into x plus 1 and x minus 1.
Then
Okay.
we already have that too.
And we already have that. So our common denominator here is actually going to be x plus 1, x minus 1. Ooh, sorry. I definitely said minus, but wrote plus.
Oh, I didn't notice though.
Okay. So our common denominator
Does two positive equal negative
when you multiply,
when you add?
2 positives equals a positive. When you add,
What about when you subtract?
it depends which one's bigger. It's going to be x plus 1 and x minus 1. So what we can do, write our originals and multiply x plus 1, x minus 1 to every single one. I know it's a lot of writing, but it's a little bit easier to visualize by writing that whole thing out. So here, x minus 1 cancels in that first fraction. X plus 1 cancels in that second. And x plus 1 and x minus 1 cancel in the last. So what we're left with is x
Squared
And then for this, I'm actually just writing out what the distribution is, but if you are comfortable going right in, go ahead. And the only reason is because of this minus sign here.
Oh.
Because that minus sign needs to be distributed as well. And if you're okay with remembering to do that, that's totally fine. So we have x squared plus x minus x plus 1 equals 2x. Because again, we had to distribute this -1 there and there. Okay? All right. So those took away.
Wait, what?
A positive x and a negative x.
Oh no, I wrote a 2
Oh,
instead
okay.
of an X.
So when we move this 2x to the other side by subtracting it, we get x squared minus 2x plus 1 equals 0.
Oh.
So this factors x minus 1 times x minus 1 equals 0. So x equals 1. But that's an issue. If we try to plug that in, you see how it makes the denominator 0 in this case? Here, 1 minus 1 is 0. You guys are going to hate me. That means there's no solution. Because if it ever makes your denominator 0, you have to get rid of that solution, and that was my only solution, so... And again, the reasoning, because it would make the denominator 0. Which we can't divide by 0. So as a recap so far, if you have variables on both sides, try to get it to one side and factor. If you have fractions, find what your common denominator would be and multiply every single numerator by that common denominator so you can cancel. Radicals. To get rid of a square root, you have to square both sides. Because the squared and the square root cancel one another out. So x squared equals 6x minus x to the third. Let's get everything to one side. Minus 6x over here, plus x to the third, also over there. And what you'll notice, none of them have the exact same exponents. So I'm going to write them from biggest exponent down to smallest exponent. What do you notice about these three?
They all have X's.
They all have x's. X squared plus x minus 6. This stuff inside we can factor. So x, and then x plus 3, x minus 2. So what are my options for x once we finish solving? We've got 0 here. When you solve that, that's going to be x equals -3. And when you solve that, that's going to be x equals 2. Now what you're going to want to do is check to make sure that it works in the original. I can tell you now, this one does not work Because the square root of something is not a negative if the square root is already written. It doesn't say plus or minus. The square root has to be positive.
The last typo that was
Yeah.
five
Okay.
there.
Because otherwise they just.
Exactly. So the other ones are true. Okay?
So,
And we're going to skip 5. So it's just x equals 0 and x equals 2 are your two solutions.
oh, okay, so you only need 2 solutions?
Yep. Sometimes you might have 1, you might have 2. It all depends on what actually works.
Okay.
Okay? Now, sometimes we're going to be solving things that have really messy exponents.
Oh, whoa.
And to get rid of those exponents, you do the reciprocal power of what that exponent is, which means you take the flipped version of that exponent. When the number in your numerator of that exponent is odd, you don't have to do anything with those signs. You keep the sign that it is. But when the numerator of that exponent is even, you must have a plus or minus. And I'll show you why in number 7. Nope, number 8. So our goal is to get the x to whatever power by itself. It's already that way in number 6. So what we're going to do is raise both sides to the 5/3 power. Raise it to the 5/3 power. So that cancels. X equals 8 to the 5/3. And you can actually type this in your calculator. If you have the calculators that are up there, you can type in 8, the little caret button, and then do 5 divided by 3. And it'll give you an answer.
You want me to do that?
I can tell you right now, 2 to the 5th, that's 32. This means you're taking the third root of 8, meaning what number times itself 3 times gives you 8. That's 2 times 2 times 2 is 8. And then you're doing that number times itself 5 times. I know. So this is your exponent, and the denominator is your root. What I want you to do, try to get this stuff by itself. See if you can figure out what to do to get that by itself. And I'll be back in a second once I get people away from my door. What's that?
I wanted to see if, we work on it.
Where are you supposed to be? Not here. Go. I'm about to send you back. You've got about 30 seconds to get the correct thing out now.
I did my document.
It's on the,
Do you need a worksheet? What is it called?
you don't wanna get on my stuff.
I didn't feel like I should write sheets too.
Wait, but what if I want 2 floors in my house?
Then make 2 different floor plans. I gave you the worksheet.
Master room should have been
I
upstairs.
gave it to you yesterday. I don't have an extra.
Okay.
You're right, you're right. I think that might be my thing. I think I might have it in my.
Well, this is my
Should
dream
have.
house.
I don't have it in my bag.
Can you guys please stop? Because I am still recording.
Wait, where are you even recording?
on my iPad.
Oh,
Like-
so it's just audio?
Like,
Oh, it's audio and video.
Oh.
I do it for all of my classes when I'm giving notes.
You have to cut off certain parts.
I'm not. I
Hey,
put it up there as it is.
look at that, I got it.
Wait.
Good.
Dan, I didn't know you were a YouTuber.
All right, so here, what we're gonna do is divide by two, or excuse me, add 30 first.
Oh.
So, like, if this had been 2x minus 30 equals 24. Same idea, it's just the x in this case is a whole lot of messy. So, we're gonna get rid of the minus 30 first by adding 30.
Oh wait, I thought you meant like.
It's okay.
When I'm just mathematic, I'm feeling Wait, so on these, all these ones are
And then-
cross method?
We're gonna divide by 2 on both sides.
No, but I'm good.
So 2x minus 1, 3 over 2 equals 27. Thank you. Yeah, yep, thank you. Now that I have stuff to an exponent by itself, I'm gonna do the reciprocal exponent.
Is he making fun of you?
Yep.
I'm gonna guess you're tired of people coming in your room to make it, so you put it in the hallway. Okay, makes sense.
See, look, he got it. So 2x minus 1. So this exponent means what times itself 3 times gives you 27? 3. So, because 3 times 3 times 3 is 27. The third root of 27 is 3. And then we square it. What is 3 squared? Yep. And you're allowed to use your calculator for this, so,
Okay.
which is totally fine. Now, this looks like something that's pretty easy to solve, hopefully. You're gonna add 1.
$11.
Guys, shh. Please. And then divide by 2. So what does x equal?
5.
There we go. That's it.
7.
Ta-da.
We depends on what you get on there.
Okay, number 8. Same idea. It's already isolated for you.
Yeah.
It's already got the messy part to the exponent by itself. We got to get rid of that exponent. So we're going to do 3 over 2. 3 over 2 means you're doing the square root of that number and then raising it to the third power. Because it's even, this means square root, which means you need your plus or minus. Only time you need it. Even, you need plus or minus. So we have 3x minus 1 equals plus or minus, what's the square root of 4? 2. And then 2 times 2 times 2 is 8. So when you do this, you have 3x minus 1 equals 8, or 3x minus 1 equals negative 8. That's what that plus or minus means. It could be the positive version or the negative version. And then you can solve just like before. Where are you going?
Bathroom.
So 3x equals 9, or 3x equals negative 7.
90 question?
X equals 3. x equals -7/3. So basically, anytime you have messy exponents, get that messy exponent piece by itself, and then raise it to the flipped version of that exponent.
And if it's even, it's
Yep.
plus or minus.
Yep. So really good things to put on that yellow, or the yellow sheet.
Yeah.
Jen, number 3 and number 4 in the box number. What about number 5 and number 6? All 4 of them?
Okay. Inequalities. Biggest thing with inequalities, if you multiply or divide both sides by a negative number, flip the sign. And I should say flip the inequality sign.
This is so small. It's so cute. That's adorable. Did you make these stars? Yeah, good.
Okay. Goal is to get x by itself. Divide by 2, divide by 2. It doesn't matter if our answer is a negative, if the stuff that's underneath or multiplied is both negative. That's when we flip. In this case, we don't have to flip anything because we did a positive thing to both sides. So we have x is less than -1. This might seem really silly, but think about it like an alligator. It wants to eat the bigger number.
Mm-hmm.
So when x is at the pointed part, it means x is smaller. When x is smaller, you're going left. So when we're graphing it, because there's no line underneath this inequality here, it is an open circle. It's at -1, and it's going left. Okay? Next one. We're going to distribute that to 7x minus 11 less than 2x minus 6. Get all the x's on one side, numbers on the other.
So this doesn't matter right now?
Nope. Okay. So I'm going to subtract the 2x. So I have 5x minus 11 is less than -6.
And then we want the x by.
So we're going to add 11. 5x is less than 5. Divide by 5 on both sides. X, we keep the sign, and that's 1. We didn't have to flip anything because I didn't have to multiply or divide both sides by a negative. So when I graph this, I guess I should probably have written a little bit smaller. My important number is 1. X is smaller again.
Really helping.
Open, because there's no line underneath it. And going to the left. What's that?
Oh. Okay. Josie told me to tell you she's still missing this number 11 here, Jersey,
Oh, okay.
and she needs it. Otherwise, you won't be getting your diploma.
Oh
until
my
it's returned.
god.
That's how serious they are about this because they've been
I'm gonna
missing.
say, it's literally on my wall at home.
Okay, yeah. Hand it in. That's how it's going with any uniforms this year.
Yes.
Thank you.
She
And that was all
Exposed
recorded
me.
too.
Yeah. No. Crystal is on one.
She is all over these recordings today.
Gonna email me.
All right. Next one, same idea. Subtract 8 from both sides. We have a negative 3x is greater than or equal to negative 6. Here, we're dividing both sides by a negative. Can the rest of you please be quiet? Because we're dividing both sides by a negative, we flip that inequality sign. So x less than or equal to a positive 2. Hey, zip of the lips.
So then the circle's gonna be filled in now.
Yep, means the circle's gonna be filled in. Closed circle, but x is still smaller in this case, because it's at the pointed part.
Yeah.
There you go. Same idea for the other ones. Do you think we need to go through, do you want to go through one of the two?
Sure.
Okay. So, idea behind this. Distribute. Distribute. 7x plus 2 minus 20 minus 4x is less than 2x minus 2. Good. Combine like terms first just because it makes it a little bit easier. The 7x and the minus 4x make a positive 3x, and the 2 minus 20 is a negative 18. Oops. Is less than 2x minus 2. So, I can subtract 2x to get it to the other side. So we're left with x minus 18 is less than negative 2. And then add 18 to both sides. So x is less than 16. Open or closed?
Whoa, I have to draw doors.
Open. Open. And is x bigger or smaller? Smaller. So it goes left. We're gonna skip 6. And 7. Ha! Let's skip to 8. When it says or, think about it like oars in a boat. If you're thinking of a canoe, they go out opposite directions. Or means they're going away from one another.
Okay.
So when you have a number line at 2, a negative 3,
to the office, please. Marceline Sanapa to the office.
at negative 3, is it open or closed?
Close.
Closed because it has that line underneath and x is smaller. But at 2, it's open and it's going bigger. If we wanted to do this in something called interval notation, you always read it from left to right. So over here, this means it's starting at negative infinity and it keeps going until I get to 3. It stops at 3. So this is negative infinity until negative 3. Does it include negative 3? Meaning, is it closed?
Yeah.
Yes, so we have a bracket. Bracket means it's holding on tight. It includes that number. Then U means there's a gap. And then it starts again at 2. But does 2 include?
No.
No, because it's open. So that's going to be a parenthesis. It's like, I'm holding on, but at arm's length. And it keeps going until a positive infinity. So again, it's starting all the way on the left, keeps going until we get to 3 and stops. It starts right after 2 and keeps going until the end.
Oh, okay.
Okay. I'm going to skip 9 as well, because it's similar to all the other stuff that we have done so far. Same thing with 10. Okay. And means it's everything in between. So if we have a number line, we've got -2 to the left and 5 to the right. Got to make sure you put it in order of the regular number lines. At 5, it's going to be open and going to the left. At -2, it's closed and going to the right.
Oh, whoa.
And it's everything in between. So when you try to do this in interval notation, you're starting at -2, because there's nothing to the left of it. And it includes it, so there's a bracket, comma, you keep going until you get to 5, but it doesn't include it, so it has a parenthesis. So again, bracket means include. You can also think closed circle. And parenthesis means does not include, which is open circle. Okay. Number 12. Because this piece is in the middle, whatever we do to the middle, our goal is to get x alone in here.
Okay.
Whatever we do to the middle, we have to do to the left and the right. So we're going to subtract 3. So we have -8 is less than 2x is less than or equal to 6. And then divide by 2, but we have to do it to left, middle, and right. So -4 less than x less than or equal to 3. This is saying our solution is everything in between those. -4, 3. Open or closed at -4?
Open,
Good. Open or closed at 3?
close.
And it's everything in between. So, how would I write this in interval notation?
So does the X matter?
No,
Okay.
it's just in between those.
So it's open, so it's not included.
Good.
Parentheses, -4,
Perfect.
and then it stops at 3, and then that'd be a bracket because it's included.
Good. And that is interval notation.
Mm.
It's not as complicated as it seems, I promise.
Yeah, it's easier than the last thing.
Good. So when we have quadratic inequalities that we're trying to solve, instead of showing you the long drawn out method, I'm going to show you how to do it with a calculator. So go grab 2 calculators, please. Okay, we're going to turn them on. The first thing we want to do on our paper is to get everything on one side and 0 on the other. So we're going to subtract 5x and subtract 6. So we have x squared minus x minus 6 is greater than or equal to 0. Okay. When we talk about graphing, our graph, which is y1 here, we want to see where is the graph of this above 0.
Ava Hopitas, please report back to Mr. Brinkman's room. Ava Hopitas, please report back to Mr. Brinkman's room.
So if you click the y equals button, under y1, you want to put x squared minus x minus 6. So x is the button that says x t theta n. To get an exponent of 2, there's an actual button that says x squared. And then you have the minus button, the xt theta n button again. Minus again.
Pardon this interruption, staff.
6.
At this time, can you please do an attendance check on your classroom? If your students do not belong in that class, please tell them to go to the class that they belong in. Again, staff, please do an attendance check at this time. If you have students in your class that do not belong there or not on your roster, please send them on their way.
And then y2, we're going to put 0 in there because that's where we want to see where they intersect. Then we can click graph. I wonder if I can put a picture in this and not have it stop. So this is what it should look like.
That's like your porch, right?
It's like, think about when you come in from a garage. Everyone's skirting around the hallways. This is Jen. Yes. Sounds good. Thank you. Bye. So, when we see this, our goal is to figure out where these two parts are. We can actually solve for those on a calculator. If you press second trace, second trace, option 5 is where they intersect. So it'll ask first curve. You can just use your left and right arrow buttons to go over to that first point. Press enter, enter, enter. Move to one of the points. Enter, enter, enter. It'll actually tell you the point of intersection. We're going to treat this kind of like a number line. And that one is at -2. We can do it again. Second, trace, option 5, go over to the other point. Enter, enter, enter. This one is at 3. So our goal, again, we want to see where is that graph above 0. So if we zoom in on this, the graph is above 0 on this section and this section. Because as I'm tracing it, it's here and here. So it's not anything in between, which means here and here. Is it allowed to include based on the inequality sign?
Include, so that's close circle?
Yep. Good. So if we were to do this using parentheses and brackets, we go -infinity to -2, The -2 is in a bracket. And then from 3 to positive infinity, and 3 also has, yes, a bracket. Okay.
Are we doing that like whole time thing?
Yep, that's what you're supposed to be doing.
Will that take out on our grade?
Eventually.
But not enough to do, right?
Not right now. All right, and then we're not gonna deal with the ones that are divided. I'll move it in a second.
You want me to put them in there?
No, no, I'll move it in a second. Or not.